Hello everyone. In this session of CCNA series, I'll discuss about Ethernet shared media and point-to-point connection. Ethernet was developed at Xerox PARC between 1973 and 1974. Ethernet was designed to accommodate multiple computers that were interconnected in a shared bus topology. Ethernet is a shared media where every device has the right to send at any time. And if more than two devices send data, then a collision could occur. In shared media, the collisions were managed by CSMA or CD, also known as Carrier Sense Multiple Access or Collision Detection. To understand the CSMA CD, let's take an analogy of a group conversation. For good communication, it is important that the participants should not all speak at once, which can be confusing. Instead, they should speak one after the other, so that each participant can fully understand what the others are contributing to the discussion. Without realizing, we actually behave like this ourselves in conversation. When someone else is talking, we stand back and listen. After the other participant has finished their contribution for the time being, we wait a short period of time and only start talking when the same participant or another participant in the conversation doesn't start to say anything else. If we happen to start talking to someone else at the same time, we stop our attempt, wait a bit, and then try again. The CSMA CD process is very similar. In the CSMA CD access method, all network devices that have messages to send must listen before transmitting. If a device detects a signal from another device, it will wait for a specified amount of time before attempting to transmit. When there is no traffic detected, a device will transmit its message. While the transmission is occurring, the device continues to listen for a traffic or collision on the LAN. After the message is sent, the device returns to its default listening mode. Later on, the physical topology were also changed to a star topology using hubs. A hub is called a network hub. It is a common connection point for devices in a network. The hub contains multiple ports. In a hub, when a frame arrives at one port, it is copied to the other port so that all the segments on the LAN receive the frame. However, repeating the frame to all other ports did not solve the issue of collisions. Hub is again a shared media, and only one device could successfully transmit at a time. This type of connection is described as a half duplex communication. As more devices were added to an Ethernet network, the amount of frame collisions increased significantly. As the number of devices and subsequent data traffic increases, however, the rise in collision can have significant impact on the user's experience. A significant development that enhanced LAN performance was the introduction of switches to replace hubs in Ethernet-based networks. Switches can control the flow of data by isolating each port and sending a frame only to its proper destination, if the destination is known. Rather than sending every frame to every device, the switch reduces the number of devices receiving each frame, which in turn reduces or minimizes the possibility of collisions. It allows a full duplex communication, having a connection that can carry both transmitted and received signal at the same time. Switches are more advanced than hubs and treat each port as a separate point-to-point links. This means that bandwidth is no longer shared across the whole LAN. Therefore, the switch acts as a boundary to prevent collisions from happening across the network. That's it for this session. In my next session, I'll discuss about concepts of PoE.